Salutations, distinguished audience. We extend our warm welcome as we embark on a riveting exploration of the enigmatic realm of electromagnetism within a segment christened the Electromagnetic Nexus. Although the nomenclature may initially evoke a sense of intricacy, fear not, for we are poised to dissect this intricate subject with utmost lucidity. Electromagnetism, an intrinsic force in the tapestry of existence, quietly weaves through the fabric of our daily lives, often imperceptible yet omnipresent. In this expansive odyssey, we plunge headlong into the enchanting domain of electromagnetism, unveiling its profound influence on our world. The electromagnetic connection serves as your compass to decipher the science, applications, and enigmas of this extraordinary power that animates our reality. This is an entreaty to embark on an expedition through the electrifying annals, captivating utilizations, and the astounding potentials bestowed by electromagnetism. From the concealed forces governing our planet to the technological innovations shaping our destiny, we shall unearth the multifaceted role of electromagnetism in every facet of our existence. The chronicle of electromagnetism commences with the age-old allure of magnets. Ancient civilizations, such as the Greeks and the Chinese, stumbled upon the peculiar attributes of naturally occurring magnetic substances like lodestones, capable of both attracting and repelling objects. Little did they realize that this inquisitiveness would culminate in one of the most profound scientific revelations in human history. During the 19th century, scientific trailblazers like Hans Christian Ørsted and André-Marie Ampère conducted seminal experiments that unveiled the nexus between electricity and magnetism. Ørsted's serendipitous observation of a magnetic needle's deflection caused by an electric current and Ampère's formulation of the mathematical laws governing electromagnetism laid the bedrock for our comprehension of this captivating force. As our understanding of electromagnetism advanced, we discerned that electric currents spawned magnetic fields, and conversely, fluctuating magnetic fields could induce electric currents. This provided the groundwork for groundbreaking technologies such as generators and transformers, ushering in a revolution in our capacity to generate and disseminate electrical power. The study of electromagnetism also played an instrumental role in the evolution of telecommunications, rendering long-distance communication feasible. For example, the telegraph relied on electromagnetism to transmit electrical signals across extensive distances, serving as a precursor to the global communication networks that now underpin our modern world. However, the influence of electromagnetism extended far beyond mere wires and circuits. It unveiled the door to the exploration of light and electromagnetic waves. The revelation that light constitutes a form of electromagnetic radiation led to the unearthing of radio waves, microwaves, and even X-rays, exerting a profound impact on disparate fields such as astronomy, medical science, and wireless communication. We embark on a voyage through time, bearing witness to the birth of electromagnetism as a scientific discipline, unraveling the experiments and discoveries that laid the foundation for its integration into our contemporary world. From the unpretentious lodestone to the amalgamation of electricity and magnetism, we begin to grasp the far-reaching ramifications of this extraordinary force in our lives. We plunge into the origins of electromagnetism, from the early observations of magnetism to the seminal experiments that solidified the correlation between electricity and magnetism. Now, our focus shifts to a fundamental tenet of electromagnetism: electromagnetic fields. In the realm of science, an electromagnetic field emerges as a pivotal construct, symbolizing the intricate interplay between electric and magnetic forces. It serves as the imperceptible tapestry that permeates the expanse, transporting both energy and information through the enigma of electromagnetic waves. To grasp how electromagnetism shapes our tangible existence, one must initially apprehend the quintessence of these intricate domains. The inception of the concept of fields can be traced back to the groundbreaking work of the Scottish physicist James Clerk Maxwell. His equations elegantly amalgamated the theories of electricity and magnetism, elucidating that fluctuating electric fields engender magnetic fields, and conversely, giving rise to the propagation of electromagnetic waves? Electromagnetic waves constitute a fundamental underpinning of contemporary technology and communication. They encompass an array of waveforms, encompassing radio waves, microwaves, infrared radiation, visible light, ultraviolet rays, X-rays, and gamma rays. Each of these wave categories boasts distinct characteristics and applications. For instance, radio waves facilitate wireless communication, while X-rays find their utility in the realm of medical imaging. We shall embark on a journey through the intricate realm of electromagnetic fields and waves, plunging deep into their role in facilitating communication, powering our electronic devices, and connecting us with the vast expanse of the world at large. In this odyssey, we shall unveil the mysteries that underlie modern existence, rendering everything from cellular phones to satellite television a tangible reality. From the moment you awaken in the morning, the omnipresence of electromagnetism quietly accompanies you throughout your day. It orchestrates the symphony of your awakening through the alarm clock's shrill call and dispels the shadows with the luminosity of the light bulb. It remains in the shadows, orchestrating the seamless functionality of the multitude of devices that streamline our daily routines. Consider, for instance, your smartphone, a diminutive marvel of electromagnetism. From the responsive touch screen that dances beneath your fingertips to the ethereal wireless signals weaving a tapestry of connectivity, this device stands as a testament to the potency of electromagnetic technology. Electromagnetism is the enigmatic force that empowers your microwave to render your breakfast steaming, your refrigerator to preserve your culinary treasures, and your television to captivate your senses. It resides in the core of your automobile's engine, the intricate web of electrical wiring within your domicile, and the sinuous power lines that stretch across the landscape. However, electromagnetism is not merely an enabler of convenience, it is a sentinel of safety and security. Ponder upon the magnetic resonance imaging, MRI, contraption at the hospital, which harnesses formidable magnets to craft intricate portraits of your corporeal interior sans invasive procedures. Contemplate the electromagnetic locks that stand guard at secure portals, warding off unauthorized intrusion. Our voyage of exploration shall traverse the spectrum of gadgets, appliances, and systems that we often take for granted, unveiling the omnipresent influence of electromagnetism. From the humble light switch to the labyrinthine network of power grids, the sway of electromagnetism is truly ubiquitous. One of the most transformative facets of electromagnetism lies in its pivotal role in communication. From the nascent telegraph systems to the World Wide Web that now interconnects us, the transmission of information via electromagnetic waves has revolutionized the manner in which we engage, acquire knowledge, and disseminate ideas. Let us embark on a retrospective odyssey to delve into the evolutionary course of communication technologies propelled by electromagnetism. The telegraph, with its transmission of electrical signals through conduits, marked an early milestone, allowing messages to traverse vast distances at previously unattainable speeds, uniting people across continents. The advent of the telephone heralded a profound transformation in communication. It enabled the human voice to traverse as electrical signals through wires, ushering in an era where spoken communication transcended geographical confines. Over time, this technology evolved into the mobile phone, an engineering marvel rooted in electromagnetism, granting us the ability to carry our conversations with us, irrespective of our location. The radio extended the boundaries of communication even further. Electromagnetic waves, embodied in the form of radio waves, permitted the dissemination of music, news, and entertainment through the airwaves. Radio waves also paved the path for television, ushering moving images and visual narratives into our homes. In the present era, the Internet serves as the linchpin of global communication. It relies upon electromagnetic waves, manifesting as microwaves and radio waves, to propel data packets across the globe at the velocity of light. The consequence is a seamlessly interconnected world where information flows effortlessly, linking individuals, enterprises, and concepts across the expanse of the planet. Our odyssey shall traverse the milestones that have shaped the manner in which we connect and communicate in our contemporary world, from the initial telegraph wires to the birth of the World Wide Web. Electromagnetism's far-reaching dominion extends well past the confines of gadgets and communication devices, delving deep into the realm of medical science. From diagnostics to therapeutic interventions, this formidable force assumes a paramount role in the augmentation of human well-being. One of the most emblematic manifestations of electromagnetism's application within the medical sphere resides in the magnetic resonance imaging MRI apparatus. Through the exposure of the human corpus to a potent magnetic field and radio frequency waves, the MRI machine orchestrates intricate visualizations of a patient's internal anatomy. This non-invasive methodology affords clinicians the ability to apprehend the intricacies of internal structures, rendering it an indispensable implement for the purposes of malady diagnosis and therapeutic strategization. Radiography, encompassing the utilization of X-rays, constitutes another domain where the indispensability of electromagnetism becomes evident. X-rays harness high-energy electromagnetic radiation to penetrate bodily corporealness and sculpt images of osseous structures and other density-resplendent constituents. This technological marvel has wrought a revolution in the sphere of medical diagnostics, empowering the discernment of fractures, neoplasms, and a plethora of additional pathological conditions. Electromagnetism also finds application in transcranial magnetic stimulation (TMS), an artifice predicated on the application of electromagnetic fields to activate specific neural loci within the cerebrum. TMS manifests the potential to proffer respite in afflictions such as melancholia and migraines. Furthermore, the quintessential life-saving implements of pacemakers and defibrillators, integral for the management of cardiogenic maladies, remain contingent on the precise modulation of electrical impulses coursing through the myocardium. In this context, electromagnetism assumes a central role in the orchestration of these life-sustaining contrivances. Within the purview of biological and investigative studies, the application of electromagnetism is notably discernible in the technique known as electrophoresis. This method engenders the separation of molecular species, including the venerable DNA, contingent upon their ionic charge and spatial proportions. It consequently facilitates the scrutiny of hereditary code and the evolution of novel remedies and therapeutic modalities. In this exploration, we plunge headfirst into the electrifying realm of medical applications of electromagnetism, delving into the intricate tools and cutting-edge technologies that have catalyzed a revolution in healthcare. Our journey unveils how these innovations have not only elevated the quality of patient care but also enriched our comprehension of the intricate human anatomy. The profound impact of electromagnetism reverberates through the domain of transportation, sculpting the very way we facilitate the movement of people and cargo across the vast expanse of our planet. The paradigm shift towards electric vehicles EVs heralds a revolutionary transformation within the automotive industry. EVs harness the omnipotent force of electromagnetism to propel their wheels, eschewing traditional internal combustion engines in favor of electric motors and batteries. This transition not only mitigates greenhouse gas emissions but also heralds a reimagining of the future of personal mobility. In the sphere of public transportation, electromagnetism plays an indispensable role in the operation of trains, trams, and subways. Electric locomotives and multiple unit trains draw their vigor from overhead wires or a third rail, effectively and sustainably ferrying passengers through the urban landscape via the alchemy of electromagnetism. Furthermore, the concept of electromagnetic propulsion stands at the vanguard of transportation's future. Take, for instance, magnetic levitation maglev trains, which utilize magnetic fields to levitate and propel trains without direct contact with conventional tracks. This groundbreaking technology possesses the potential to metamorphose high-speed rail travel, rendering it faster and more ecologically efficient. Nonetheless, the dominion of transportation transcends terrestrial boundaries. The aerospace sector leans heavily on electromagnetism for a multifarious array of applications. From radar systems that guide aircraft to satellite technology underpinning global positioning systems (GPS), These innovations have irrevocably transformed air travel and navigation. We embark on a journey to explore the electrifying strides made in the realm of transportation, as electromagnetism unfurls new horizons in the way we transport people and commodities. Whether on terra firma, traversing the open seas, or soaring through the boundless skies, electromagnetism is steering us towards a more sustainable and interlinked future. In the epoch of digitalization, electromagnetism quietly assumes the role of the unsung hero, powering our technological marvels from the shadows. Semiconductors occupy the heart of modern electronics, their functionality intricately interwoven with the tapestry of electromagnetism. Transistors, the fundamental building blocks of electronic devices, orchestrate the ebb and flow of electrical currents through the medium of electric fields. These minuscule components have facilitated the miniaturization of electronic contraptions, bequeathing us the ubiquitous smartphones, laptops, and tablets that have become indispensable in our daily lives. Integrated circuits and microprocessors, animated by the vitality of electricity, stand as the intellectual powerhouses fueling the technological renaissance. They process information, administer tasks, and conspire to make contemporary computing feasible. Electromagnetism also assumes a pivotal role in data storage, with magnetic fields orchestrating the reading and inscription of data in hard drives and solid-state drives. In the realm of wireless technology, electromagnetism assumes a pivotal role, facilitating connectivity among our myriad devices. The likes of Wi-Fi, Bluetooth, and cellular networks depend upon the transmission of data via radio waves, ensuring a seamless exchange of information. These technological marvels have revolutionized our modes of labor, social interaction, and access to knowledge. Furthermore, within the backdrop of security systems and environmental surveillance, electromagnetic sensors and detectors quietly stand as sentinels. Consider magnetic sensors, which possess the ability to discern alterations within a magnetic field. These devices find application in compasses, navigation systems, and even some smartphones, contributing to functionalities like screen orientation. This investigation unveils the innovations that have metamorphosed our existence, reshaping the way we operate, interact, and entertain ourselves in the digital realm. Electromagnetism's influence extends beyond the confines of our gadgets and contraptions. It wields its power over our connection with the natural world. A vital facet of this connection lies in the realm of sustainable energy. Electromagnetism empowers solar panels and wind turbines, harnessing the sun's and wind's energies to engender electricity. These sources of clean energy are indispensable in our mission to diminish our reliance on fossil fuels and alleviate the repercussions of climate change. The Earth's magnetic field also serves as a subject of scrutiny, with electromagnetism contributing to our comprehension of its intricate dynamics. Geomagnetic tempests, originating from the interplay between the solar wind and the Earth's magnetic field, can impact power grids, communication systems, and even navigation. Grasping the intricacies of these phenomena is imperative to the safeguarding of our technological infrastructure. The natural world, in itself, teems with electromagnetic marvels. Diverse creatures, such as avian and aquatic species, rely upon the Earth's magnetic field for navigation. Meanwhile, insects like bees utilize the polarization of light to locate nectar. These natural phenomena serve as testament to the intricate interplay between electromagnetism and the environment. The realm of environmental monitoring ushers forth another captivating dimension for electromagnetism's application. Remote sensing technologies pivot upon electromagnetic waves to scrutinize the Earth's terrain, atmosphere, and oceans. These innovative tools yield invaluable data for the monitoring of climate shifts, the tracking of natural calamities, and the preservation of our planet's well-being. Within our expedition through the electrifying realm of electromagnetism, we bear witness to its profound influence on the domains of science, technology, and society. We gaze into the proverbial crystal ball, delving into the future of electromagnetism and its potential to shape our world even more profoundly. The realm of electromagnetism opens doors to intriguing frontiers, most notably in the realm of quantum technologies. Quantum computing, in particular, harnesses the idiosyncratic attributes of quantum bits, or qubits, to execute intricate computations at an exponentially accelerated pace compared to conventional computing systems. Electromagnetism takes on a crucial role in upholding the delicate quantum states indispensable for the seamless operation of these apparatuses. Another avenue of notable advancement lies in the creation of more efficient and sustainable energy solutions. Electromagnetic technologies, such as the wireless